Okay, so this is a little bit of a, well, quite a step here we're making between solving systems of equations, where we can use the substitution method, and this one where we're solving a system of inequalities. Your instinct last time was to graph and get a picture of it. Let's start, in this case, by getting a picture of these two inequalities. And then we can go from there to see what it looks like, what we might want to do. So for graphing the first,
you'll pull out a point at 1, and then up 4 and over 1.
Up 4, 1, 2, 3, 4, and over 1. Up, if I can only go up 2, I'd have to go up. Oh, I'd have to go over a half, yeah. If I go down 1, 2, 3, 4, I'd have to go to the left. Okay, so there it is, and it's a strict inequality. So the points on the line,
to the left of that.
But how do I draw the line first?
Dotted.
Dotted. Okay, so we're going to draw a dotted line. Again, your ruler is going to nail that down a little better. And we're going to, oh, I'm sorry, and then, yeah, we have to shade a region.
Yeah, to the left of it.
To the left. Okay, I'm going to use usually above or below. I understand left to right because of the way this line is oriented. So to the left. Right, so that shaded region works. Okay, now I'm going to change my pen color here to green, and we'll graph this one.
Okay, so up 3.
We'll go to 3.
And then up 2 over 1.
Up 2 over 1, it picks up that point.
Up 2 over 1. And then down 2 over 1. Down 2 over 1.
Okay.
And this line is filled.
That's true. This one is solid, so we're going to be able to use the other tool, and we're going to graph it, and it's shaded what region?
It's below it.
Below the line. So we're going to shade off this way. Okay? Now the problem is that's a big mess.
Yeah.
And it doesn't tell us what we're really interested in, which ultimately is
point of intersection.
Well, we're looking for the set of points which solve the system. Now, that means solving the system means we want to make this condition true and we want to make this condition true. Okay? So, if I pick this point, does this point make the blue condition true?
No.
No. Does it make the green condition true?
Yeah.
Does it solve the system?
No.
No. Okay, it doesn't solve the system because it doesn't make both conditions true. Terrific. So this one is garbage. We'll get rid of it in a minute. How about a point out here?
No.
You say no, why?
Because it doesn't work for both.
Doesn't work for both. Doesn't, in particular, doesn't work for the green.
Yeah.
Okay. And a point here. Does that work?
Yeah.
That works. It's above the blue and below the green, and so it does work. Okay, good. So if we were here, we didn't like that point. We didn't like that point. We did like that point. Okay, we're going to keep it. So what works? Do the points on the green line work?
No. Or yeah.
Well, yeah. So, yes and no.
Less and equal to.
This one does, right? Does this one?
Yeah.
It's on the green.
Yeah.
Does it work for the blue?
Yeah.
Yes. How about this point out here?
Yeah.
It's on the green.
But it's not past the blue.
But it's not above the blue. So no, we're going to get rid of this one. Okay, it's gone. Okay, so in order to work, they have to be on. Can you tell me in English how It's going to have to work.
They would have to be on the green line and still in the blue shaded region.
Yeah. Okay, so on the green line, well, actually that's a tough part right there. All right, so we're going to plot a whole bunch of points. This point works. This point works. This point works. This point.
No.
No. Okay. Can you describe the, well, let's see. So the area that actually works is the intersection of the green and the blue, right? So it's really this kind of triangular shaped wedge. Is that right?
Yeah.
Okay. But on that triangular shaped wedge, the points that are on the dotted blue, do they work?
No.
No. If it's on the dotted blue, it doesn't work. So this point, which is on the dotted blue,
Doesn't work.
does not work. So that's an open circle there. It does not work. The stuff along the dotted blue does not work, right? The stuff on the green does work, and everything in here works. Okay? So that's our final answer. It's a bit of a mess. With some experience, it won't be as messy. But it's the intersection of the two sets. This flag is a good marker, but we're marking a corner boundary that's not ours. We don't own that flag because it's on the dotted blue, and the dotted blue is not in this condition. Anything along here is part of the solution. Anything in between here is part of the solution. This does not work, this doesn't work, this doesn't work. Okay? Terrific. So how would we find that coordinate?
1, 2, 3, 4, 5, 1, 5.
It is the 0.15 because you can read it off the graph.
Yeah.
Okay. If it were a weird, ugly fraction and not something we couldn't read, if we could not read it off the graph, then we'd have to solve y equals, I'll put it in not this crazy ink, but I would have to solve the equations y equals 4x plus 1 and y equals 2x plus 3 and use our substitution method so that 4x plus 1 equals 2x plus 3, 2x equals 2, x equals 1. If x equals 1, 4 and 1 make 5, y equals 5, the 0.15. That's how we get it algebraically. Same substitution method we just did. Okay? This is the problem I remember making up. Easier point of intersection. I must have been, okay, not paying attention to the other one. Ready?